Hello, we are discussing about GATE 2003 ECE paper, and this question is related to analog circuits. The circuit shown in the figure is best described as, look at the circuit diagram, whether it is bridge rectifier, ring modulator, frequency discriminator or voltage doubler, that you have to identify. Okay, the circuit is consisting of two diodes and two capacitors, so that we are naming the diodes like this. This is D1 diode 1 and it is diode 2, and this is capacitor 1 C1 and it is capacitor C2, and output we are making it as V0, and this V0 is between plus and minus. We are taking the terminals as this is plus and it is minus. So voltage across this point is nothing but Vc1, voltage across this point is Vc2. So you can write V0 is equal to Vc1 minus Vc2. Okay, and assume that this is what the input signal we are applying. This is V input, and V input is a sinusoidal signal. As you are looking at this diagram, this is a sinusoidal notation. So V input is going to be a sinusoidal signal. V input is a sinusoidal signal. We are going with the magnitude as sinusoidal signal with magnitude as Vm. So the signal is going to be oscillate sinusoidally between plus Vm and minus Vm. So this is going to be the diagram for the sinusoidal signal. So this is highest peak is going to be plus Vm. Highest peak is plus Vm. This is plus Vm, and lowest peak is nothing but minus Vm. And it is having two half cycles. One we can say it as positive half cycle, the other is nothing but negative half cycle. If you observe positive half cycle, all the voltages are going to be positive only. If you observe positive half cycle, all the voltages within this positive half cycle is positive, and all the voltages within this negative half cycle at any instant of time, the voltage in the negative half cycle is always negative. So that we can classify this operation of this circuit into two categories, that is two cases. One is during positive half cycle, the other is nothing but during negative half cycle. Okay, so now we will see the operation. This is what the given diagram. Okay, and now case 1. Case 1, that is nothing but first case A. During positive half cycle, during positive half cycle, during positive half cycle is nothing but the signal is going to be initially it is going with, it is increasing from 0 to Vm, it is increasing from 0 to Vm, later it is decreasing from Vm to 0. So I am taking it as first case, and this is second one, that is nothing but sub cases. So during, whenever, that is nothing but 0 to pi by 2. So first one is nothing but I am going with whenever the omega t is between 0 to pi by 2. By that time V input is going to be increasing from 0 to Vm, and that makes you are applying positive voltages for the diode 1 as well as diode 2. But this voltage is making diode 1 forward bias and diode 2 reverse bias. Because for diode 1, for P side you are applying positive voltage, but for diode 2, N side you are applying positive voltage. So diode 1 forward bias, diode 2 reverse bias. Okay, and we assume that diode is ideal, so that the forward resistance of diode is 0, and the time constants required for the capacitor charging, so tau c charging time constant is nothing but product of R into C. R is nothing but forward resistance of diode and capacitance value. For ideal diode, forward resistance is 0, so that 0 into something is 0. So within no time the capacitor charges. So the within no time the capacitor charges is nothing but as you apply the input signal, the capacitor charges. So we can say finally at omega t is equal to pi by 2, since V input is equal to Vm, at that instant itself the capacitor 1 charges to Vm. Okay, and it charges to Vm like this, plus minus in this way. Since the current is flowing in this direction during positive half cycle, capacitor is going to be charges plus minus. Okay, and now the voltage across capacitor is Vm with the polarity as shown, plus minus. If now we are going for the second case, during this second case, omega t is going to be from pi by 2 to pi. During this one, okay, the voltage across this one is going to be, voltage across the diode is now decreasing because V input is decreasing from Vm to 0. So always the voltage across the diode P side is less than Vm only because it is now reducing from Vm onwards. So always the diode voltage across P side is going to be less than Vm, whereas for N side it is at constant of Vm because capacitor C1 has charged to Vm. So now you are getting Vm over here N side of the diode D1 and P side is nothing but less than Vm. So this makes diode 1 to become reverse bias, and diode 2 as usual it is reverse bias because you are applying positive voltage for the N side. So now capacitor doesn't find any discharge path because diode is under reverse bias D1, so that under reverse bias ideal diode act as open circuit. So open circuit implies nothing but there is no discharge path, so that this Vc is going to be constant at Vm only. Vc1 is going to be constant at Vm during this pi by 2 to pi only. So pi by 2 to pi also the capacitor voltage is going to be constant at Vm. Okay, and next now we are going for the other case, that is case B. Case B is nothing but during negative half cycle. During negative half cycle. During negative half cycle, again we are going for the two things because during negative half cycle also, as you are applying the voltage. The voltage is going to be decreasing from 0 to minus Vm, 0 to minus Vm, and increases from minus Vm to 0 again. Increases from minus Vm to 0 again. Okay, by that time what happens to this diode? Okay, so again we are going for the omega t. Omega t is going to be between pi by pi to 3 pi by 2. Pi to 3 pi by 2, that is nothing but exactly this point. Okay, so sorry, exactly this point during these two positions. Okay, where the input signal you are applying is decreasing from 0 to minus Vm. As you are applying negative voltages, this makes diode 1 to become reverse bias because diode 1 is going to be, you are applying negative voltage for the P side, and diode 2 is nothing but it will become forward bias. Diode 2 is forward bias. Once the diode 2 is forward bias, it is assumed as ideal diode, so that now the capacitor charges, but the current is flowing in this direction. Look at the direction of current. Now the current, always whenever the diode is forward bias, current flows from P to N. So now the capacitor C2 charges with the polarity as shown. This is plus and it is minus. So minus plus, the Vc2 is nothing but now. Okay, Vc2 charges with time constant as Tf is equal tau f, time constant, charging time constant tau c is equal to Rf into C. Rf is forward resistance of diode 2, and since it is ideal it will be taken as 0 into C2. Okay, whereas this is C1, you can write C2. So C2 is equal to 0 into something is 0. Within no time the capacitor charges, so that at omega t is equal to 3 pi by 2, by that time input voltage is reaching minus Vm, so that voltage across capacitor C2 is also reaches minus Vm. So it is going to be equal to minus Vm. Okay, now you are applying maximum negative voltage of the input signal you are applying towards P side, and N side if you are going for the second case. Okay, N side if you observe the second case, omega t is from 3 pi by 2 to 2 pi. During this one you are applying more positive voltage than Vm. the voltage is going to be now increasing from minus Vm towards 0. That is, you are applying more positive voltage towards N side than the voltage on P side. Voltage on P side is minus Vm. Okay, voltage at N side is you are applying more positive voltage. So that makes diode D2 is reverse bias along with diode D1. So D1 and D2 both are going to be now reverse bias. So now diode D2 act as open circuit. So capacitor C2 doesn't find any discharge path. By that time Vc2 will become Vm. Okay, Vc2 will become minus Vm. So now V0 that is nothing but output voltage is defined as Vc1 minus Vc2. Vc1 minus Vc2. Vc1 is nothing but Vm, whereas Vc2 is nothing but minus Vm. So minus into minus it will become plus. Vm plus Vm is nothing but 2Vm. So the output voltage is nothing but twice of the input signal magnitude. So that it is 2Vm. So that this circuit is act as voltage doubler. This circuit act as voltage doubler. So the right answer for this one is nothing but answer is D. So answer is D for this one. Thank you.